All right, third graders, we are on to math corrections. These are for week 5, day 4, so let's just get right to it. Oops, I shared the wrong thing. So sorry. Let's try again. Here we go. Perfect. Let's zoom out a tiny bit. Push it up a little bit. Here we go. Hopefully that's focused in a little bit. All right, week 5, day 4. Again, just like language arts, this is the last day of math practice for the week on these sheets. That means all 4 days should be finished. All right, let's look at number 1. There's always 2 equations typically, and there's something that they have in common. So that's what I always want you looking at. When I look at these two, 80 minus 4 and 90 minus 4, I notice that they both are subtracting 4. These two are different when I look in the tens place. This one has one more 10 than this one. So let's see if that can help us at all. If I'm taking 4 away from 80, I'm going to be left with 76. Now I could have done a couple things. I could have counted backwards. That would probably be my easiest if I said 80, 79, 78, 77, 76. I also could have rewritten my problem vertically, that's up and down, and then I could start in my ones place. I have to do some ungrouping to get some ones for my 0, 6, and 7. All right, that would be another way. That's a little bit more intense. As I look at 90 minus 4, remember I'm thinking, what did it have in common? How can this one help me solve this one? Well, if there's one more 10 here and the 4 is the same, that means that the ones place is going to stay the same. So it'll be a 6. But that just means when I subtract, there's going to be one more 10. So 1 more than 7 would be 8. So 86. All right, give yourself a mark. Number 2 has multiplication and division. Remember, this is another division symbol. We haven't looked at division a whole lot. Let's look at this. 5 times 1. There's a rule. Anything times 1 always equals itself. So this equals 5. You can also remember your 5 count by. This means 5, we're going to count by 5 one time, and that would just be 5. Simple. All right, this is what we consider long division, even though this is a very short problem. And the way I read this is I start with the total. Remember, division, we always start by saying the total. It's on the inside. I say 5 divided by 1. What I'm thinking in my head is 1 times what can get me to 5? And I know 1 times 5 will get me to 5. And I have to put the 5 right above the number inside. Okay? We'll continue practicing like that. As our multiplication grows, our division will grow as well. All right, for number 3, we have measuring. This is part of a centimeter stick or a centimeter ruler, and we're measuring how long this stick is. I can see 4 centimeters and 5. This is right in the middle. I think we talked about this last week. When it's in the middle, we call that a half. We can say 1/2, right? So we would say this stick is 4.5 centimeters. So you can write a fraction 1/2 like this or at a diagonal like this. They are the same thing. So it's 4.5 centimeters. Okay. Remember, if you didn't write this or you need to change it if you didn't get it correct, this is your time. You're correcting right now. Okay? Number 4, write the correct symbol in the circle. So we're going to be comparing less than, equal to, or greater than. Okay, here we go. 699, 966. They have a lot of the same numbers, but if I start in the largest place, the hundreds, there's a 6 and a 9. 9 is bigger. My alligator likes to eat the biggest number, so I would have less than in the circle. 699 is less than 966. Okay, let's look at the next one. 1001 and 999. I already noticed something. The number on the left, it has an extra digit. It has 4 digits. That means it goes into the thousands place. The number on the right only has 3 digits. It only goes into the hundreds. I know 4 digits, thousands, are bigger than hundreds. So 1001 is greater than 999. Okay? Give yourself a mark for that. Number 5, we like to end with those word problems. A baby elephant is about 3 feet tall when it is born. How much will the elephant have to grow to be 12 feet tall as an adult? I'm going to get my highlighter. I'm going to highlight some important information. And I see 3 feet tall when it is born. And then my question, how much will it have to grow to be 12 feet as an adult? Well, I can tell there's a missing number here, so I'm going to think about this. I've got, if I want to use addition, I know that the baby elephant wants to grow up to be 12 feet when it's all grown. So that's going to be the total that I'm trying to get to. And the baby already has 3 feet when he's born or she's born, right? So my missing number, and I could put an F for feet, I could use a variable. I'm thinking 3 plus how many more feet will get me to 12? I could count on. I'll start with 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be 9 more feet. So F equals 9. So 9 feet is the answer. You may have thought of this as a subtraction problem. Remember, subtraction and addition, they're the inverse. They're the opposite of each other. So maybe you thought of, start with your total, 12 minus 3, and see how many feet are left. We could use F as our variable. Once I do that subtraction, I'm going to still come up with F as 9 feet. Okay? Make sure for the word problems, you've chosen an equation to show your work. You're not just showing 9. I want to see how you solved these. Okay? Give yourself a mark. Well done, third graders. That's it for day 4, week 5. See you soon.